It just kept telling me, you know, I was waiting to join, so not sure what happened. Okay, good morning, everybody. Good to see you, or not. I want to give a breakdown about lithium batteries instead of lead acid battery technology for use in, getting the seat properly, for use in mainly QRP, perhaps SOTA use. I also use them if I'm on holiday. I take these little packs with me. So I'll run through, I won't give you all my background, but I've been licensed since '75. I've worked in the battery technology a good part of my life. I still use them for radio, and I also use them for flying model aircraft. Okay, just quickly, people call cells batteries and they call batteries cells. Difference between a cell and a battery. A cell is that single, you know, AA cell or whatever, and a battery is when they're all joined together. So you get a battery pack like that with its 3 cells joined together. It's the only difference. Called a battery, they think, because Benjamin Franklin, who was playing about with Leyden jars and joining them all up into like huge capacitors, basically, thought they looked a bit like batteries of cannons, and it stuck. If you put 2 dissimilar metals in an electrolyte, so in something that's a conductive liquid, whether it's an alkaline or an acid, that will start to produce power. When I was in education, I used to take a potato in and put a little piece of copper in it. I think I used to put a piece of nickel in it because we had metal available there. But you can use a nail and something that's plated and something that's unplated. Into a potato, you'll get about 0.9 of a volt. I had a little digital watch running for over 9 months on a potato. And the only thing that stopped it working is the potato got dehydrated. So the electrolyte disappears. What you get is ions or electrons going between the positive, negative plates and back. First cell that we know of, and there's still a lot of debate over this, is what's called the Baghdad cell, found in made in 250 BC, found just outside of Iraq, and it looks to all of us very much like a battery. On the right-hand side, it's a sketch that the archaeologists made, and the other couple of pictures are constructions that either people have made or have drawn up, and just to explain it a bit further. But it was a copper rod, a copper case, an iron rod, and keeping those 2 apart was an electrolyte. They don't think they knew what electricity was particularly. They think it could possibly have been used for gold or silver plating. They used to do a lot of gilding as well, but that's the original battery. Inside, if you open up a AA cell, whether it's rechargeable or not, you've basically got what's shown here. A case with what the green is a semi-solid electrolyte, it's usually an alkaline. That's why if they leak, they mess up all your battery connectors in the device. When it's charging, the power goes into the battery and loads it back up with electrons, and when it discharges, obviously the opposite happens. Going to go through the types of cell. Today we use nickel hydrides. You'll see them as NiMHs. NiCads are basically illegal because of the cadmium in it, and when they were put into refuse tips, cadmium would leak out into the water systems, and it's not a pleasant metal. Fairly popular. You can get a good range of them, but probably for our use, we'd probably use what they call the slow discharge, and any loop are the originals. But these days, nearly everybody does them, even IKEA do them these days. They work well. They'll produce 1.2 volts a cell. You can series them up. You can't parallel these up. You can, but you will get problems. Quite liked, as with all batteries I've listed here They don't like being over discharged. Any battery pack or a cell on its own, you should always really cut it off when there's still 20% left. That's how you'll get the maximum life. These any loops will last a couple of years, a good year charged, and only lose a small percentage of the charge. Whereas the original, if you have the young long life versions, they'll lose 20% about the first week, and then it goes down, and after a month or so you haven't got an awful lot left. They're fairly easy to charge. You charge them by controlling the current. The original way of charging them was to take the capacity and divide it by 10 and feed that current in. So if you've got a 12-volt power supply, and you can put a resistor in series with that, which will drop the current flowing through the battery. If we class these on the slide here as 2 amp hours, you could charge each of those at 200 milliamp hours, so C10. The modern charger will actually knock a lot more charge into them. They will take much higher currents. They'll get warm. If you go too high, you'll write them off. They'll gas out basically. Although they look sealed, they have a little tiny gas vent on them. Okay. Sealed lead acids. This is probably the one we're all familiar with if we go out QRPing or climbing up mountains or hills and we want a source of power. 7 amp hours, 12 volts, really fits in with what we would normally use. It's what I always used myself. Sensibly priced, about 25 to 30 pounds here. If you get a branded make, you can get some really cheap ones, but with all battery types, you get what you pay for. UASA are a very good make. Used to have a big factory up in Wales. They're a Japanese battery, but all the parts come here. They're assembled in Wales. The worldwide company now. Fairly easy to charge. Usually you put 2.3 volts a cell across them. So to float charge a 12 volt one, you put 13.8 volts across it. If you want to charge it quicker, you can put up to 2.45 volts a cell. But you do need to monitor the current, not put too much current in. And when the battery is charged, that's when the current starts to drop. You must drop that higher voltage down to 2.3 volts a cell. Easy to make an automatic charger to do that. I used to make them, I used to design them at one time. Again, don't like deep discharging. If you deep discharge this type of battery pack, it will actually, once it gets below the 20% and it carries on down, it will then go very, very high resistance, and a conventional charger just won't get any charge to go through it. There are ways of recovering them. Doesn't always work, but I'm quite happy to tell somebody on their own about it. But it is, to do that, it's a fairly dangerous thing to do. You need to monitor what you're doing. One big problem with lead acid is the discharge curve. The voltage drops away quite steeply, and I'll show some curves against lithium later. So that, 12, 13, about 13.2 volts will drop away quite quickly. And of course, if our voltage drops, any output from your transmitter is going to drop. Beauty with lithium, it's reasonably constant, but I said I will show a curve. Another big problem with this, of course, you've got, in this type of battery I'm showing here, you've got 84 watts of power basically. But your big problem is it weighs 2.2 kilograms or 4.85 pounds. What I class as 2 bags of sugar. Bag of sugar used to be £2, now it's a kilo. Quite a lot if you're walking up a hill. It was always the heaviest thing I ever took with me. Lithium polymer type cells, you've got plates that are coated with usually an aluminium plate that's got a lithium cobalt material on one plate and a lithium carbon on the other, and with a microporous separator. Basically you have like a polyethylene separator, which is as near as it can be visible to the flow current, and that's loaded with lithium salts. You'll see a basic picture down on the side. You can also get a lithium manganese loaded plate instead of cobalt. That actually, manganese is slightly environmentally more friendly than cobalt. How a lithium ion battery works, this basically is the same for any battery. To discharge it, this is just a very quick animation. It just gives an idea of what's happening. You'll get the current or the lithium current flowing in that direction on discharge, and on charge, it reverses the direction. It's quicker to show you. So if you see what's happening. So that's discharge. Then on charge, those lithium ions move back. Okay, just gives you an idea what's happening. Current flows from negative to the positive, by the way. Lithium ion cells themselves. Open this up, I've got a few here. That's a single lithium ion cell. If you've got a Dyson Hoover, or you've got a conventional type, what I call a Windows type computer, you'll have a pack of lithium cells in them. This is a pack that I took apart that came out of a Dyson Hoover. The reason was it was a new pack, and then the actual piece of equipment failed. So I kept the battery pack, stripped it out, and you can strip them out, and you've got a 3.7 volt nominal voltage on the cell. Usually with lithium, you can't do with most other types of cells, is you can series parallel them. So if you wanted 3.7 volts at 100 amps, you could just parallel up. You know, if your cell is a 2 amp hour cell, you could parallel up 50 of them, and you'll have a 100 amp pack. The battery pack we're all used to, the lead acid is that type of case. But you can now buy these cases empty on eBay. They come with 2 pieces that look like this, and into each of these you can plug a lithium cell, and then you can connect them as you want them. What people often do will put 4 in parallel and then put 4 lots of those in series, and then just drop them straight in the box, glue the lid on, wire it, glue the lid on. It's quite an expensive thing to do, because each of those cells, you know, depending where you get them from, are expensive. But that is one way you can do it. Basically, this cell is like wound up very much like a big capacitor. Long plate assembly, and it's wound, as you can see in that picture. They'll produce a nominal 3.7 volts per cell, but most of that is higher after they've been charged, and it will drop back down. You get a very high weight, energy rate per weight with these. Slow self-discharge. Once you charge them, they'll sit on the shelf for as long as you want, nearly. They're lightweight, but again, don't like over-discharging. These are the sort of cells that I use for radio use. And I also use them with aircraft, called lithium poly, or LiPo. If you look up LiPo cells, put in LiPo cell or battery, otherwise you'll get liposuction. If you're searching for it, really good. This is a direct equivalent to the old 12 volt 7 amp hour lead acid pack. Very high energy per weight, slow discharge again. You have to charge lithium properly. Lead acid's quite forgiving. Lithium isn't. Number of things will happen, and they can even burst or catch fire. But that's only if you bang the wrong charger on them. This pack I've just shown you, I'll put it down out the way now, has a voltage of something like 16.8 volts after charge, and it will drop back after a little while on discharge to about 14.8. The high voltage can be a problem. What I did was, if I can lay my hands on it, was to, I made up a box like this and it's got a lithium in and output plug on each end. I can plug that pack on it at high voltage, and what it will do is it monitors the voltage of the battery pack. It drops a couple of diodes in series with the pack until the voltage drops to around the 14.5 volts, fully adjustable, by the way. And then it will take those out of circuit and the battery will carry on as it should, but your transceiver will probably like it a lot more. Most transceivers don't like higher voltage than probably, what, 14 and a half. That stops it. I can do a circuit of that, perhaps put it in a G-QRP magazine if anybody would like to see it. I also have in there a thing called a polyfuse. I'll explain those a little bit later through. Okay, the better type to get, and they are becoming more popular, in fact I showed those the wrong way round just now, are the lithium ferrophosphate. So it's got lithium, iron, and a phosphate in it. The beauty with it is a 4-cell pack produces somewhere around 13.2 volts. It's ideal for us. Couldn't be better. That pack I showed you has got 55 watts of energy in it. Same as the one shown on the picture here. The main benefit with these is that although it's got less energy than the sealed lead acid, the voltage doesn't drop off the same. So you've actually got a higher terminal voltage until the battery's virtually discharged. They need charging correctly, and again, 3.65 volts a cell, but you use the right charger. They're fairly expensive. That pack is, that's right, £38.21 from Hobby King. Hobby King's are worldwide. They started off selling model aircraft parts and drones, batteries, chargers, and so on. So anybody in the world could use Hobby King. There probably is a Hobby King depot somewhere near you. But the other big benefit, it only weighs 535 grams. So it's it's half a bag of sugar. And I put it again in pounds, because I appreciate we've got some USA people online. So it's £1.03 ounces. If you consider the sealed lead acid was nearly £5, and you've not got a lot difference in the energy. The other thing you can do with these batteries, if you take two with you, you can put them in parallel if you want. So you could get 8,400 milliamps capacity. The big thing you've got to be careful with these is they can dissipate huge amounts of current if you short them. While we use them in aircraft, I have a friend who flies a lot of ducted fan aircraft. I'll show you something a little bit later. And he's drawing over 3 kilowatts out of the batteries while he's flying. You fly it for about 6 minutes. These batteries are made to do it. On our use, we don't tend to be doing that to them. Best way to check these, because the one critical thing with lithium is not to over discharge. If you do, the battery can actually go into a quite unstable state. Lithium poly is a lot less stable than lithium ion. So you get these little battery monitors. I have one of these in circuit all the time. I'm using them. When the battery cell gets to a critical level, it will bleep at me. I'm going to close it up because the sound is, these are designed to be in aircraft. So you can hear them when they fly past you. I'm going to plug it in. And what that will do on my pack, it'll show me, can you see that? If I put that up, I don't know if that's backwards or not. It might be because of the way I'm holding it, but it'll show you all 12 volts, and then it'll tell you the voltage of each cell itself. And you just leave it in circuit, and when that pack gets down to its 20%, its danger level, which is normally 3 volts a cell, that alarm will go off. These are a couple of pounds on eBay, Amazon, or wherever you want to go. Really worth using. If the buzzer annoys you, block it up with some blue tack or plasticine. You can get another type, which I've got here again, like this. And these again are slightly more sophisticated, quite a bit dearer. you're talking 12, 15 pounds, so around the $20, but they've got a much better screen on them. They will also trigger an alarm when something goes wrong, and you can check the conditions all the way through what goes on. It's just a dearer version, but it does the same job basically. Lithium is used, of course, in space. Only recently, NASA sent up a number of new lithium packs for the International Space Station. I do talk about that, and do have some dealings with NASA on that particular side of things. But if you can remember the Dreamliner, the Boeing that kept having the problem with the battery up in the tail of it when they launched the plane originally, it was a lithium cell. It wasn't being charged properly. How that happened, I don't know, but it's been corrected. Lithium cells, batteries, I keep emphasizing this, it's vitally charge them properly. Don't get the old car battery charger out of the boot or out of the garage. You're going to hit a problem. It's like I say, you'll probably nuke the cells. If you do it, it's your responsibility. Your packs won't last long. Use the right type of charger. I've picked two here. I deal with a company called Overlander. I buy from them. I don't have anything else to do with them, but I use their pictures. They gave me their pictures for an article I wrote recently. But I've picked the bottom and the top range of their chargers, and this will be the same around the world. This one is £25 basically. So what's that, about $32? It will charge 2 to 4 cells, which I've got up here. It'll do 4 to 8 nickel hydrides. I don't touch nickel cads now. It'll run off the mains. Its output power is 30 watts maximum. So obviously if you put a 5 amp hour battery pack on it, you're going to have to charge it at a lower level, but you can select that. What these chargers will do, they're very good. Normally they will sense the battery you put on. My charger, which I've had for years, looks like that. It's programmable. When I plug a battery into it, it senses what battery I've got. It will sense the number of cells and then gives me the option to select along here what I want to charge it at. This one is very basic, but it will do the job. So if you've got a battery pack, you know, you're invested in a lithium for QRP use, this is about the cheapest charge you can get. You can get cheaper on eBay again, but I always say, you pay your money, you take your choice. Right at the other end, and this is £85, so about $100, you've got the very sophisticated one. It's a 100-watt charger. You can actually charge and discharge with this. So you can cycle a battery. It'll output 10 amps maximum. It'll discharge up to 5 amps, and that will do each cell. This will also charge lipos, or any of the lithium cells. It'll do NiCads. It'll also do lead acids. I used to charge my old 12-volt 7 amp hour on it until that failed finally. It will also balance the cells out, because you do get variation in the cells. Well worth it. Mine, I just showed you, was nowhere near that price. Mine, I think, was about £35. If you want to go right the other end, you've got a 400-watt charger there. It's got 2 chargers in the system, mains all battery operated, but you're talking big money, £225. Okay, when you charge them properly, each cell's monitored when they charge. All these packs have the main lead. I use these connectors, by the way, called XT60s. They'll take 60 amps. I do them for 2 reasons. They fit the aircraft and they fit my QRP type equipment. On them, they always have a little terminal block like this. When you plug them in a charger, that goes in. This goes in another little socket, which I can probably show you here, is on the side. You can see them there. Main battery would go in those 2. The little tiny plug goes in there. And during charge, every cell is monitored to see what's going on. So if one cell's slightly lower than the other, it will bring that one up more. Quite, quite an effective system. Lithium technology, I've said earlier, you can series parallel as much as you want. You'll see often if you buy them, something marked as 4S2P. Just means 4 cells in series in parallel with another 4 cells in series. You can actually buy them. I think mine actually is made like that one I showed you. As you buy it, it's a 2100 milliamp hour in parallel with another 2100 milliamp hour pack. And you can charge them like that. And I put provided the charger will have sufficient current to do the charging. You'll still need to make sure you've plugged in the extra battery sense terminals. You can do it, depends on the battery and the charger. I emphasize this regularly. Batteries don't like being over discharged. Even a car battery, if you over discharge it, it's a job to get it to recharge. Most modern car batteries are what they call lead calcium. That is a more modern technology. It came out when I used to work for Oldham Batteries. But if you deeply discharge, you'll kill the battery quite quickly. It starts to throw the material out the plates. You have got deep discharge batteries. You used to get, well, you get them on fork trucks. We used to have them on milk floats. They would take a much lower discharge curve, but they're constructed differently to allow for that. When you're charging or when you're carrying them, I always recommend these little LiPo bags. They're glass fiber flame-proof bags. Mine is like that, and one of these packs, just to show you, will go straight in it. In fact, I can get 2 in there with a squeeze. So if I'm packing them, I tend to put them in the bag, mainly because although they're sealed over connectors, that just makes sure you're not going to have an accident with it. And very cheap. Power meters, these things are brilliant. I don't know why all amateurs don't use these. These things are about 12 to 15 pounds. It's got a chip in it, heavy connectors on it. And if you plug this in series with your battery, and I'll just show it quick. I made a desoldering fan up. It's got a filter in the front. Came out of an old laptop power, an old computer power supply. And I run that actually off of one of my lithium packs. I'm going to plug that into the meter here. And then if I plug that into my battery pack, the fan is now running, and I expect you can see on screen. Does that look backwards to you?
Oh, that looks good. We can read that.
Oh, that's okay. I think it's just I've got it, it's coming up on my screen. But it will show that this does current, voltage, and wattage. That's drawing 3.9 to 4 watts, but it'll also show a peak current and a peak wattage. They're really good. If you're running battery power, they're really worth having. That will also tell you the state of the battery. And again, I've just plugged the 2 plugs on the end. I wouldn't be without that. Lead acid, okay, battery capacity or cell capacity is always measured in watts per kilogram. Lead acid, you get about 30 watts a kilogram. Lithium, you get somewhere between 100 and 240 or 243. It just depends on the technology of the product and whether it's an industrial or the type I buy. But you can see you get a lot more energy per kilogram of weight. I did put in nickel hydrides here. Not too bad. They're much lighter, probably 4 times as good. Petrol has got 12, nearly 13,000 watts per kilogram if you take its energy. And if you can find yourself a deuterium battery, you've got 160 billion watts per kilogram. Pretty reactive stuff. Okay, just to quickly show you, that's the Vulcan bomber that runs on the lithium packs. This friend of mine, used to captain the Vulcan bombers himself. He was a Vulcan bomber pilot. And they did a show out near Corfe Castle, and the plane flew past the castle. it got picked up by somebody because they thought it was a real Vulcan, of course, and it was all over our newspapers the next day. And it was Cyril's 10-foot wingspan Vulcan. But that thing, I said, draws over 3 kilowatts when it's flying. When he fired that up on a bench one day, it took 2 of us on each, well, 1 of us on each wing to hold it back while he opened the throttle up. Brushless motors, they're efficient as well. Okay, just quick comparison. If you use what we used to use, the sealed lead acid, 84 watts, weighs 2.2 kilos, easy to charge. A lithium poly, which will produce up to 16.8 volts, is 84 watts again, but you down it, 0.5 kilogram. And the lithium ferric phosphate is 55 watts and weighs 472 grams, but you could take a pair of those with you. I'm not going to cover Perkins equations. You can calculate if you increase the current, how much it would discharge by. It's a completely different talk. But as you increase the current, the actual discharge time, of course, shortens. It seems fairly obvious, but there is a formula to actually calculate it. Discharge curves, just to give you an idea, the red curve here is a lithium ion battery, so any of the LiPo cells, and the lead acid, you can see it drops away quite quickly. You can see that the lithium ion keeps its voltage nearly until it flips over at the end, when there's about 80% of its capacity gone. And that, of course, will output or will affect your transmitting power when you're on the air. So again, lithium, although you're spending a bit more for it, you've got to buy the charger, you actually will benefit because it's light and you get as much as you can out of the battery before it goes into a big discharge. So you get nearly all of its capacity. Discharge cutoff voltages, normally with a lead acid, you cut off at 1.7 volt a cell, so 10.5 volts. Depends how deeply you discharge it. LiPo's 12 volts, that's when you ought to be cutting it off. And the lithium ferrophosphate, 10.8 volts a cell. Again, the little device I showed you that will monitor the battery, it's got a little switch on it, and you can set that to the trigger voltages you want. I normally set all of mine to 3 volts a cell because I find it makes the battery last well. Lithium will tend to last longer as well, cycle-wise, than lead acid, but it depends what you're doing with it. Safety, all batteries can dissipate huge currents. Protect with a poly fuse or a glass fuse. I use poly fuses. I used to use these when I was working with the MOD. A poly fuse, I'll just hook one out. In fact, probably better if I actually show in a moment. And charge and discharge them correctly. I think I've got a page on poly fuses. Safety, don't keep them in your pockets. When people fly aircraft, they often walk around with one of these battery packs in the pocket. That can dissipate some around 100 amps instantly. If you directly short it, it'll dissipate some around 200. They put it in the pocket with a loose change, their keys and so on. And I always say to them, remember what the battery's near, if it's in your pocket. So do put them somewhere safely. Polyfuses, just to quickly cover these, polyfuses are really quite a clever device. It's a little tiny chip, basically. It's a material that is very, very low resistance up to its rated value. And this one showing here is a 5 amp one. When you overload that, it's usually double the current. So if we put 10 amps on it, it will go high resistance. And it will go very high resistance and just isolate the system. I was using these for military because where they were and what we were doing, you didn't have time to change fuses. You probably didn't have one anyway. These things are brilliant. They reset. And I said in use, you're talking something like 0.022 of an ohm. It's hardly worth worrying about. You'll probably find the leads connecting it will be dropping that or more. Easy to get hold of, by the way. You can get them from most of the big electronics company. I deal with a company in the UK called bitsbox.co.uk. Brilliant for components. What they sell is branded, and I get the poly switches from those. And my little battery protection box, besides switching the voltage over, it's got a polyfuse inside. So I haven't got to worry about, putting one in circuit or trying to wire one in. Just to summarize, lithium is light and they pack power. They do cost more. They probably cost 20, 30% more than lead acid, but they'll last longer. They're lighter. You need the right charger, of course. Hold the voltage very much easier, and they can be series paralleled, and they've got a long shelf life. I won't run the video now because I don't think we've got time, but this I'm showing in the chap's hand is a radio controlled aircraft. It's running on a lithium battery. It's about the size of a small postage stamp. If you built model aircraft when you were children from the Airfix kits, this is the same size as those 1/72 scale planes. This thing flies just brilliantly. I'm not running the video because I'm aware of the time. Finally, remember, you get what you pay for. If you buy cheap, you'll get cheap. I tend to buy something branded, especially with battery technology, because I find it works. You can very quickly test it. Some of the Chinese packs that are sold have nowhere near the capacity that's written on the outside. I'm not against Chinese battery packs because the couple I got from Hobby King come from there, but they are monitored. They're proper companies selling them. Okay, I think that's about it. Happy to take any questions, if you've got any.
Oh, there's quite a list of questions for you, Bill.
Good.
I've written down a few. Let's start with one that's just popped up recently. Is there a real benefit of lithium ferrous versus lithium potassium battery for QRP radio use?
Yes, there are. The LiPos, I call them, the standard lithium poly, has got that much higher voltage. So you've got to get rid of that. Or you could use 3 cells, but then you tend to be down around 11 volts, which is probably too low for what we need. My little QRP transceiver is one of the little UKITS ones. That's all right, because that'll take 9 to 14 volts, but it only puts a few watts out anyway. But some are more critical. So you've normally got to drop that down if you're using what I call a 4-cell pack. Whereas the lithium ferrophosphate have a lower terminal voltage. So you're down to about 13.2 to 13.8. So normally you can put that straight on the transceiver. The discharge curve is the same. They tend to be a little dearer, probably 10% or more dearer than the standard LiPo, but they are also less reactive. So they're a little bit more forgiving if you get the charging set wrong. Otherwise, there's nothing in them really. So higher voltage, which we've got to get rid of, and less reactive than the standard LiPo. I hope that answers it.
Yeah, that's real good. On that same question as a follow-up, what about the life cycle on both of those types of batteries?
Okay, if you're going for lead acid, does depend what you do with them. If you look at any manufacturer's recommendations, they'll say 800 to 1,000 cycles. We even used to do that when I was working for Oldham Batteries. I was in sales and the technical side of it, but you'd be really lucky to get it, to be honest with you. Normally, probably the type of use we're doing, you're probably talking 100 to 200 recharges with lead acid. There are exceptions. With lithium, you're probably talking 400 to 500, but it does depend again how you treat them. But they too tend to last longer. Not a lot of difference in the actual discharge, self-discharge curve, but I'm a big believer. I use all lithium cells these days. I only use nickel hydride where I can't get a lithium cell in. I don't know if I showed these packs, by the way. You can get an AA cell, put them in these little containers. Now you've got a C cell and there's a D cell, all running off the original lithium cells. Easy to get hold of. Just lithium, sorry, AA cell adapters. Okay, does that answer the question about the life cycle?
Oh, sure, that's good.
Good.
On the, I have one question from Dominic on shipping and travel. You mentioned about carrying them in your pockets and such, but what about traveling with lithium batteries, either as checked baggage or as carry-on baggage?
Good question. I tried to answer it yesterday, and then something, although I wasn't given the talk, I was answering somebody else's who were talking about QRP, traveling with it. The law or the regulation up until recently, and I can't find a new update to it, so I assume it's the same, certainly in the UK, is that you could carry, it had to go in the hold, but you could have 100 watts of battery. So if you've got a 12 amp hour, 7 amp battery, sorry, 12 volt, 7 amp hour battery, we've got the 84 watts, so that would legally travel. And if we got the lithium 500 milliamp hour, 5 amp hour, you've got 84 watts again, that is still okay to go in. But they won't let you take that on hand luggage. It has to go in the hold. The only thing I'd ever say, if you do that, you've got no problem with them, but you can actually get blanking plates that push on the end of these little blanking covers, which will actually make it even more protected. If I take that, I tend to, that's my cell, I tend to put it down like that, and I put a bit of tape around it, just so this is not floating around anyway. It's not perhaps that, but it's something cut through the lead. But they would all go in the hold, and all of my batteries, they go in some bubble wrap, you know that, and go in a box. So they're safe. And mark the outside of the box if you're going to go on a hold, go on an aircraft. But you would have to check with the airline. But internationally at one time, it was 100 watts of battery power. Does that answer it?
Yeah, that's very good.
Good.
We do have a comment that in the US at least, you have to carry on versus put in the hold certain wattages of battery or certain capacity batteries. So I think there's a little variation in some of the requirements for that. But going on to another question on the discharge rates of batteries. I know that, for example, a car battery has a different discharge rate. It's not as suitable for QRP or radio use because it has a high amperage out to be able to start an engine versus a lead acid and then again to lithium. Can you expand on that?
Yes, the car batteries, I mean, they'll work, but I wouldn't want to carry one up a mountain. You'll get lots of power, of course. Yeah, batteries, car batteries or vehicle batteries are rated with 2 ratings these days. You'll get amp hours, so you get, say, a 12 volt, 40 amp hour battery. And you'll also get what they call CCA, cold cranking amperage. Now, 40 amp hour battery has probably got cold cranking is when you turn the key to start it. You'll probably find it's got a 300 amp or a 400 amp cold cranking ability that will only last for a short time. And when the battery's made, it's actually the surface area of the plate, because they've all got separate plates in them, that will give you the CCA, the cold cranking, and the thickness of the plate gives you the amp hour capacity. I wouldn't say that they're that suitable for the main reason, because of weight. You can get what they call leisure batteries. Leisure battery basically these days is a car battery that's just got a different top on it and a handle. There's very little other differences in them. You still need to monitor to make sure you don't over discharge. As I said, lead acid, if you go below about 10%, they can go very high resistance and they're really difficult to get back. I said there are ways of doing it, but I'd rather not broadcast that because there are some safety aspects that people need to do. But if somebody emailed me, more than happy to give them the details. Does that answer that?
Yeah, very good. Yeah.
Great.
I'd like to go into a little bit on the same vein as discharge rates, the longevity of a charge on a battery with respect to the load on, say, a QRP rig. I've seen some discussion as to amp hours and what size battery someone should buy based upon the rig that they're using. Say a typical QRP rig at 5 watts. Should they buy a 9 amp hour or a 12 amp hour battery? Do you have any insight on that?
Yeah, I'd come back on that. I mean, I think the cycle is a third transmit, 2/3 listening, or 25% transmit and 75% listening. So the current's varying. Obviously, most current's going out when you're on transmit. I think the whole thing comes down to how long you want to be on the air for. If you're doing a field day, you want to be up there all day, I would think you probably need 12, perhaps 15 amp hours of batteries. The one thing you can do again is to take, say, 2, 3 of those with you. You still haven't got the same weight as the 7 amp hour lead acid. Obviously, you've got more weight. That's about half a kilogram, which I think is about a pound. So you'd still only have about 3 pounds of weight. Charge them all up before you went, because they hold the charge really well. You can go back to those a year later and they're still charged. They've dropped a little bit, but they're still charged. But it comes down to, and we're lucky with QRP, we don't need huge battery packs. If you're running 100 watts, you're going to want car batteries or truck batteries. But you just calculate what current you're going to use, multiply it for how long you want to run it for. The amp hour rate basically is the amp hours until the battery gets down to that 20% critical point when you should cut the load off the battery anyway. That's when my little battery alarm would go off. So if it's 5 amp hours at 80% used, my alarm will go off. So you get the full 5 amperes basically in that 80% of use. I'm not sure if that answers it or not, but I said it depends basically on how long you want to be on the air for, and then calculate the time you're on against the time you're listening. So I think with my little tiny rig, it's a couple of 100 milliamps listening, and I think it's about 1.5 amps a link transmit. So my little packs, again, I can still get probably a morning or an afternoon out of it. So a day I could get away with 2 packs. It's basically why I have these 2 bigger packs. That would operate for a day. I hope that covers it. If you do that, of course, you want a couple of these as well, the little sensor.
Okay. 2 more questions and then we'll wrap it up.
Yeah.
One question that came through is about supplementing field battery use with a solar panel. They have a variety of portable solar panels you can take out with, say, a charge controller attached to with the solar panel into the battery. Can you expand on that? Do you have any experience with using the solar panels?
If you use solar panels, yeah, certainly with lithium, you've got to know where the voltage is. It depends on what you're using. I can't remember the voltage per cell on solar panels, but I think it also depends on the technology. But if it was me, you've got your charge regulator that's, say, coming out at 12 volts. One thing, I couldn't find the charger. One thing with my, yeah, that's right. One thing with my charger here is that normally runs on mains, but it'll also take in there 11 to 18 volts DC. So you could take the output of the charge regulator, long as it's within that, feed it into the charger and put the battery on the other end. I appreciate you're going to lose some inefficiency, through the charger. But you can't really do anything about that. You're going to lose some in a voltage regulator. But that's what I would do. I've never done it. But if that's what I was doing, that would be my approach. I hope that helps.
Okay, that's good. We'll have to wrap it up. We're running out of time. This has been very, very pleasant and very informative. I would like to follow up. If you could please submit your circuit to Sprat for that diode voltage drop monitor. I've had several people ask for that. And I think that would be great to have that as a follow-up in Sprat if you could do that. But thank you so much again for the 150 or so that attended to this presentation. We really enjoyed it and it was very, very informative. Thanks so much for bringing this on.
Thanks for listening and putting up with me for the last 15 minutes. And yeah, I get that. It's about Tex Swan, actually, who's the editor, only lives a few roads down from where I am. I know him very well, so I'll have a word with him anyway.
Okay, great.
I will get that done. Thanks very much. Good.
Thank you. Okay, we're going to go ahead and end this right now, and then we're going on to the next set of presentations. There's also the chat room feature, although I'm not quite sure how that is working right now or not, but that starts in about 5 minutes. But thanks again, and we shall see you all on the next session.
Great. Thank you. Okay, bye.
Bye.